Hi friends! In this video we're going to talk about multi-step linear equations. I really should add that linear in there because we're still dealing with equations where the variable is raised to the first power. Now in the previous video we talked about how in order to combine like terms we want to do our addition and subtraction before the multiplication and division. And now we're going to expand that concept a little bit further to include slightly more complicated equations. So I want to write up a little bit of maybe a pattern to follow when we're solving multi-step linear equations. So the first thing we want to do is to distribute. So we want to deal with any parentheses, brackets, or grouping symbols that need to be distributed. The next thing that we're going to do is we're going to combine on each side of the equal sign. All right, after we combine, or collect like terms, that's another way to say it, then we're going to use our addition or subtraction. And then finally, our multiplication and division. And I just want to say these last two steps, this is just a two-step linear equation. Like we talked about in the previous video. So this is all of our new stuff to deal with. But it's really not all that new. You know about collecting like terms and distributing into parentheses, so it's not so bad. Let's take a look at one. So I have an equation. Oop, not an equals there, that's a plus. All right, I have 2 times parentheses, x minus 4, close parentheses, plus 3x is equal to 2. All right, so our first step up there tells us that we need to distribute into those parentheses. So that means that the 2 is going to get multiplied into the parentheses containing the x minus 4. So 2 gets multiplied by x to get 2x, and 2 gets multiplied by negative 4 to get minus 8. And then I'm going to rewrite the rest, plus 3x, and then equals 2 on the next line so that I can then evaluate what I'm going to do next. It's important to not skip steps on these types of problems because that's where we lose a term or a sign, and it's hard to get a right answer once you lose part of the question. All right, look back at step number 2, and that's going to be combine on each side of the equal sign. So if I look at this left side of the equal sign, I have some like terms I can combine. It's the 2x and the 3x. So I'm going to combine those together and write them as 5x. Now we don't want to forget that minus 8 on the front, so I'd have minus 8 plus 5x is equal to 2. Notice that the sign on the 8 stays with it. So that where it's minus 8 in the first line, it's negative 8 when we rewrite it. All right, at this point, we just have a two-step linear equation. So we're going to look for those like terms of negative 8 and positive 2, and we're going to use addition or subtraction to combine those two terms. Now, I'd like to get the variable on one side and all the numbers on the other side. So I need this negative 8, I need it moved away from the x. So in order to undo minus 8, we are going to add 8 to both sides. Minus 8 plus 8 Those undo each other, so we're left with 0. So on the left-hand side, we have 5x is equal to 2 plus 8 on the right side is equal to 10. All right, we are almost done. We're at a one-step linear equation. I have 5x. We want to undo multiplication by 5. So we are going to use its opposite, which is division. 5x over 5 is just going to leave me with 1x, or we just write x. 10 divided by 5 on the right-hand side is 2. So we get to an answer of x is equal to 2. I know I'm finished because I have a variable by itself and a number on the other side. Let's try another one of these. All right, so I have 3 times parentheses, 2x minus 1, close parentheses, plus 5 is equal to x plus 4. And I always like to double check that I've got the problem written down right, because it's really easy to just transpose something or lose the negative. All right, looking at our list of steps, remember the first step is to distribute. So we are going to distribute this 3 into both terms inside those parentheses. So we'll have 3 times 2x gives us 6x, and 3 times negative 1 is minus 3. Everything else just gets written down. So on the next line, I have 6x minus 3 plus 5 is equal to x plus 4. Our next step is combine. So let's look on each side of our equal sign. Where do we have like terms? On the left side of the equal sign, I have a minus 3 and a plus 5, and we can combine those two numbers together. Minus 3 plus 5 is just 2. So when I rewrite the left side of my equation, I have 6x plus 2 equals x plus 4. Keep in mind that the 6x and the 2 are not like terms, so we can't combine them. Same with the x and the 4. Those two can't be combined either. But what we can do is use addition and subtraction to get all of our x's on one side and all of our numbers on the other. So I'm going to start with the x's. I've marked my like terms of 6x and x, and I'm going to get all the x's on the left-hand side. That x is positive, so to undo it will be minus x. X minus x means those two just go away or equal 0. 6x minus x is 5x. So I have 5x plus 2 is equal to 4. All right, I have another set of like terms, and that is the 2 and the 4, and I'll use addition and subtraction to get those two combined on the same side. I want to undo plus 2 by subtracting 2. Plus 2 and minus 2 undo one another, so I'm just left with a 5x on the left-hand side is equal to 4 minus 2 is equal to 2. All right, one final step. 5x equals 2. That's a one-step equation. X is being multiplied by 5. So to undo that, we will divide by 5. 5 over 5 gives me 1. So on the left-hand side, I have 1x, or x, is equal to 2/5. Now, let's talk about 2/5. In college algebra, your teacher's going to want your answers to be exact. And what that means is no decimals. They're going to want it in a fraction. A fraction that's been reduced, yes, but definitely a fraction. So it's a good time to get in the habit of leaving your answers in this form rather than putting them in the calculator to get a decimal approximation. All right, let's look at one more example. And this one's going to be a little longer, so I'm going to start it right here in the middle. So I have x plus 4 minus 3, parentheses, x minus 2 is equal to 2 times x minus 1. We've got two sets of parentheses here to deal with, and that's okay. We'll go ahead and deal with those in one step. So this negative 3 is going to get multiplied into the parentheses x minus 2. And then on the right-hand side, the 2 is going to get multiplied by the x minus 1 in parentheses. All right, let's go ahead and do this step. So where we started with the x plus 4, I'll just write that down again. Don't lose this negative, it's super important. So I have minus 3 times x is minus 3x. Minus 3 times negative 2 is going to be plus 6. And then on the right-hand side, 2 times x is 2x. 2 times negative 1 is minus 2. All right, let's look for like terms. On the left-hand side, I have an x and a minus 3x. And I also have a positive 4 and a positive 6. I'm going to combine all of those in one step. So my x minus 3x, remember this is a 1x minus 3x, would be minus 2x. Plus 4 and plus 6 makes plus 10. So when I rewrite the equation, I have minus 2x plus 10 equals 2x minus 2. And let's see. So we want to combine our, not go that color, minus 2x and our 2x. Now be really careful here. They're opposite signs, but they're on either side of the equal sign. So let's be careful. I'm going to get all of my x's on the right-hand side and my numbers on the left. So in order to do that, I am going to add 2x to both sides. On that left-hand side where I had minus 2x plus x, those are going to undo one another, and I'll be left with 0 plus 10. On the right-hand side, I have 2x plus 2x is 4x, and then minus 2. We want to combine the minus 2 and the 10. In order to do that, I'm going to add 2 to both sides. Minus 2 plus 2 undoes each other. 10 plus 2 is 12, so I have 12 is equal to 4x. We're finally at a one-step equation. To undo x being multiplied by 4, we're going to divide by 4. Those 4's will cancel, and I'll be left with a 1. So x is equal to 12 divided by 4 is 3. All right, in the next video, we'll explore what happens when we include fractions.